equal to k q1 q2 over r square. In this, f inversely proportional to square of the distance. Means if we put anything, any charge nearer to it, and the position of charge is gradually increases, the force of attraction or repulsion decreases. That is, the force of influence continuously decrease with respect to distance. As the distance increase, force decreases, and at this point it becomes zero. That's why I said this is the boundary line. At this point its influence is zero. So where the influence is zero, here mathematically if we see, to make this force zero, we can take r as infinity. Here the force is zero, all other things are constant. So f proportional to, mathematically it is f proportional to 1 upon r square. For f to be 0, f0 proportional to 1 upon r square proportional to 1 upon 0, r proportional to 1 upon, you can say it is root 0, that is 0, then 1 upon 0, that is infinity. It means to make the force 0, the distance should be infinity. Infinity in mathematics, also you will hear that infinity. Infinity means in that it is very long. But in our case, infinity means where its influence become nil. There is no influence. So this is the infinity for this charge. So the whole boundary line can be considered. Beyond that also it is infinity. But this is, from here the infinity starts. It is not like mathematics, the infinity is very long, we don't know where it is. But in this case, for this magnitude of charge, the infinity starts from this point. So this is the infinity point. At this point its influence is 0. Now, if we take a charge, that charge is unit positive charge. This is unit positive charge. That is unit positive charge represented by Q naught. Its magnitude is unit. It is very small. And that unit positive charge is placed at this position. So that means the unit positive charge is placed at infinity. To bring this unit positive charge from infinity to any point inside this space. One more thing I should say, that the space around this charge in which it can exert force on the other is known as electric field. It is electric field. So this space around this charge, that is electric field. Here we are putting this unit positive charge which is at infinity. From infinity, if we want to bring that from infinity to any point inside the electric field, definitely the work has to be done. The force is to be applied. When we apply the force, the work is done. In that case, to bring this test charge, unit positive charge from infinity to this particular point at the distance r, the work is to be done. That work done to bring unit positive charge from infinity to a particular point inside the electric field is known as electric potential. So that means electric potential is the amount of work done to bring unit positive charge from infinity to a particular point inside the electric field. That is electric potential, represented by the symbol V, capital letter V. And that is work done, amount of work done to bring that unit positive charge from infinity to a particular point inside the field. So here we get the formula. This is the electric potential. So potential is the work done. For what? To bring the charge. To bring the charge from infinity to that particular point. I think it is clear somewhat. I'm not saying completely. You understand? It is the electric potential. So around any charge, around any given charge, the work must be done to bring any other charge from infinity to that particular point inside the electric field. But the work done is not same. Suppose in the first case, here, in the first case, the test charge is brought from infinity to this point. Let us take this point is A. This point is A. And it is at this distance from Q. It is at the distance of R1. Now, if the same charge, that Q0, unit positive charge, is brought from infinity to another point, suppose this is the point B. Point B, that is at the distance of R2 from this. Here also work is to be done. So the same test charge, both are infinity. This is all the points on the circumference of the circle, or we can say in 3 dimension it is circumference of sphere. All the points are at infinity. Here we are moving from infinity to this point, moving from infinity to this point. And the distance of that charge, finally it is placed at various distance. It is at R1, it is at R2. In both the cases, the work has to be done. The unit positive charge moved from infinity to point A, infinity to point B. Since the distance from this charge is different, the work done is also different. The work done, it is also different. To move infinity from point, to move the charge from infinity to point A, some work is done. From infinity to this point, some other work is done. It is not same. So it directly gives the meaning of that at point A, there is some potential. At point B, the potential is somewhat other. So here we say this is the potential at point A. This is the potential at point B. It means at different points, to bring the test charge, unit positive charge is different. The work done is different. That's why the potential at these 2 points are different. So VA, potential at A, VB, that is potential at B. Both the points are having different potential. One may be greater, another may be smaller. Here obviously, the potential is greater at point A because it is brought closer. Now from this figure you can see that R2 is greater than R1. R2 is greater than R1. So more and more the unit positive charge is moved closer to the charge, given charge. More and more it is moved closer. More work is to be done. Here it is moved closer to Q than this one. So therefore, the work done to bring the charge at point A, it is greater than this work done. So we can say the potential at point A is greater than potential at point B. Both the points are having different potential. And we can say this is at a greater potential, this is at a smaller potential. So that means there is some difference in the potential between the points A and B. And that difference is known as potential difference. That is the potential difference. Potential difference. So potential difference is also the work done. How can we say potential difference is also the work done? Since we take these 2 points, point A, point B.